step for graphing an exponential is identifying the base of your exponent. So this is the base. Base is 2. So let's make a parent table using the base. Y equals 2 to the power of x. Now we're not going to graph this parent table. We're just making it so we can use it to apply our transformations. So you can choose your x values. So I recommend that you go from -1. If the base is 2, we can go all the way up to 3. So go ahead, figure out what your 5 y values would be. 2 to the -1, 2 to the power of 0, 2 to the first, 2 to the second, and 2 to the third. So what did you get for your 5 y values? Yep. Any questions on how to find those? 2 to the power of -1 is 1/2. Anything to the power of 0 is 1. 2 to the first is 2. 2 squared is 4. 2 cubed is 8. So we're not going to graph it. Step number 2 is identify A, H, and K. So the number in front of the base is invisible. There's an invisible 1. So A is 1. H is always in the exponent, and you flip the sign. Joshua, are you paying attention? I don't think so. All right, so what would the H value be? -3. And then K would be what? Okay, so when you apply your transformations, it's always H plus X, always H plus X. And then you take your Y value, multiply it by A, and add K. So in this example, H is -3. So we're adding -3 all the way down. So we're creating the table that we are going to graph. For your Y values, you're multiplying them by 1 and subtracting 7. So go ahead, apply your transformations, and then we'll be ready to graph the table that we get as a result of our transformations. So go ahead, take a couple minutes and figure out what your new table will be. Okay, who agrees with my green table? Who got that? All right, so let's go ahead and plot our points. So -4. Well, actually, let me back up a little bit. I think it's a good idea before you start graphing it to draw in your horizontal asymptote. So remember, your horizontal asymptote is always y equals k. So because k is -7, remember, an asymptote is a line that the graph does not cross. So I'm going to draw that in first, just so I can make sure that my graph does not go below this line. Okay, so now I'm going to graph my points. Okay, so that is my graph. Now your domain is always the same for every exponential function. It's all real numbers. Your range, because you have an asymptote, is not going to go below -7, so it'll be -7 to infinity. And we also have our y-intercept, so we can just write that below. Any questions about how we went through that graph? Now, the thing is, in your book, your homework, like I think the first one is written backwards. It says 1 plus 2 to the power of x or something like that. So sometimes the k value is written first instead of in the back. So don't let that confuse you for tomorrow's homework. Any questions about that first one? What y'all think? I don't remember how many points this question is. I'll look at it after I finish this, because I've already made copies of the test. I'll look and see how many points this is. Yes?
When is the domain not all real numbers?
For exponential, never. It's always all real numbers if it's an exponential function. Good question. So that's the point we should all get Friday, because we already know the answer. All right, let's look at number 2. So now we're going to focus on our base. The base of our exponent is 3, so let's, not -3, it's just 3. So we're going to make our parent table of y equals 3 to the x. Now we're not going to graph this table. We're just going to make it. Now we can't go up to 3 because 3 to the power of 3 is 27. So the highest we can go, if the base is anything other than 2, is probably 2. And we did not give you any bases other than 2 or 3. Because like even if we did 4 to the power of 2 is 16. That's too big. So we usually stick with base 2, base 3. Yes?
Why is it 3 and not -3?
Good question. The base cannot be negative. So that negative in front, maybe this is something you want to write down. You cannot have a negative base. Exponential has to be positive. So that negative you see is your a value. A is -1. H, what's H? +1. And what's K? +5. All right, so let's go ahead and fill in our table. Get your 4 y values. And then you will be ready to apply your transformations. Negative 9 plus 5 is negative 4. Negative 3 plus 5 is 2. Negative 1 plus 5 is 4. 5 minus 30 cents is 4.7. All right, go ahead and compare. Make sure I did it right before you trust it, because I'm trying to wake my brain up. Did you all get that same table as my green table? All right, so again, I recommend we start by graphing our horizontal asymptote, which would be what? Y. Horizontal always starts with y equals, because that's how you write a horizontal line. So what would our horizontal asymptote be? Y equals what? 5. So I'm going to draw that. Okay, so we're going to go in and it's going to come down. So because A is negative, it makes it reflect below your horizontal asymptote. So again, our domain, that does not change. And we also have our y-intercept. It was in our table, so we can fill that in. And what would be our range? Not infinity to 5. Close though.
5 to infinity.
Nope.
Negative infinity. 5 to negative infinity.
Nope.
Negative infinity to 5.
Negative infinity to 5. Ooh, that took a lot though. Ooh.
Well, because I got to remember.
Negative infinity to 5.
Oh, yeah, this thing's going up.
Yeah, because the smallest number in the world is negative infinity, so that would come first. So if it's less than, then we start with negative infinity. All right, so now let's flip it over. Below, less than.
Oh, so if it was on top of the y, or if it was on top of the 5, then it'll be 5 to infinity.
Right.
Yeah, what are you yapping about, bro?
Yeah. All right, so now let's flip it over. Let's do a couple of equations. Remember, the name of the game is finding that common base. So we got 8 and 256.
What is it? It's the back.
No, it's not.
Mark? You mentioned Marcus, right? Marcus with the dreams. Yeah, that's his name. Marcus with the dreams.
So it's kind of like trial and error here. That's the hardest part of these equations, is figuring out the common base. Thumbs up when you figure out the base. Okay, we about halfway there. So when I see something like this, I know the only way to get to 8 is 2. So if that's my only option for 8, then it has to be my option for 256. So we know that 8 is 2 to the third. And 256 is 2 to the power of 8. Now make sure you put the exponent that was there in parentheses, because you will have to distribute on both sides. Okay, you all are my first class, my first pre-cal class, so anybody want to be brave and say what you got? So I can see if it's what I got. 2 over -9, -2 over 9. Who got that? Okay. Again, it doesn't matter where you put that negative as long as it is somewhere in that fraction. So question number 4, common base will be 2. Can't go any lower than 2, so I know that I have to change the right side to be 2. 2 to what power is going to give me 8? 2 to the 3rd, bring down the x. So now I have a quadratic, which means I have 2 answers. For a quadratic, you always set it equal to 0. Okay. Wait, did I lose anybody? Are you okay? All right, we got to set it equal to 0. So we got x squared minus 3x minus 18 equals 0. Go ahead and factor that down. How did we get who?
Oh.
What would be your 2 numbers that multiplies to be -18 and adds to -6? 3 and 6. Both positive? -6, +3, or positive?
Positive 3, -6. I mean, -6, yeah. -6.
Okay, -6, +3. You just discovered Marcus?
No, I always knew Marcus. I know more about the grid.
Oh, okay. So now we're going to add the 6. And then we're going to subtract the 3, and that would be your 2 answers. So the name of the game and everything on this quiz can be written as a common base. So don't write there is no common base. Every question will have a common base. Now next week, when we finish chapter 5, then we'll talk about equations that don't have, exponential equations that don't have a common base. But for Friday's quiz, everything has a common base. All right, so let's look at question number 5. So we know that the left side is as low as it can go. And 1 over 27 is the same as 3 to the what power? -3. Yep. Go ahead, drop the base. Got another quadratic. This time, though, you cannot do a shortcut. So we're adding the 3. So you need 2 numbers that multiply to 6, add to 5. Go ahead, make your box. Factor and solve.
Gonna be sick today.
No, next week I have to take my mom to an appointment, so it'll be next week.
Oh, so you gonna be sick next week?
No, I'm not gonna be sick. I just gotta take care of family business. So what would be your numbers that multiply to 6 and add to 5? 3 and 2. Let's go ahead and take out our GCFs. So that gives us 2x plus 3 equals 0, which means x is equal to negative 3 over 2. X plus 1 equals 0. X equals negative 1. And that would be your two answers. Now, number 6, you have two options. Two different options to go about here. You could change them both. I'm going to show you both. You could change it from a 1 over 8 to 1/2. So you can use a base of 1/2 or you can use a base of 2. If you use the base 1/2, the exponents will be positive. So this will be 1/2 to the power of 3. And then 1/2 to the power of 2 is 1/4. That's one option. The other option would be to use a base of 2. And I'm not sure which one you would use, so I'm going to show you both. If you use a base 2, now your exponent would have to be a negative. So do you want to distribute a negative or not? Both of these equations will give you the exact same answer. So it's up to you. I don't know. They're the same. Both you got to distribute, so it's the same. Same amount of work. But I just want to make sure you understand that you can use a base 1/2 with a positive exponent, or you can use a base of 2 with a negative exponent. So pick the one you want to do, and I'll put up the answer here shortly. All right, what you all get? You should have got a fraction. What you get? Yeah, -4/13. Who got that?
Yes, ma'am.
That's what I got. And I used the one on the right. But again, you should get the same answer with both. All right, use the rest of this class period, work on homework 18, or start working on your study guide.